Question 8. This question is about citric acid, a hydrated tricarboxylic acid. Its formula can be represented as this. A 1.50 gram sample of this contains 0.913 grams of oxygen by mass. Sample burns completely inert to form 1.89 grams of CO2 and 0.64 grams of H2O. Show that empirical formula is this. So first things first, let's find out the moles of CO2. Mass over mR 44, yeah, because 16 for oxygen, 16 times by 2, 32, 32 plus 12, 44. So we get the moles of CO2 as 0.0430. 2. Let's find out the moles H2O. Moles of mass over mR, 0.643 over mR 18. No 0.0357. Now we need to find out the moles of hydrogen and oxygen. Now to find out the moles of oxygen, that's going to be very easy. 0.913 divided by 16. 16, which will give me 0.057. And then to find the moles of hydrogen, well, we know that the moles of H2O is 0.0357, and we know we're burning a sample, and once we burn the sample we form this many moles of H2O. Therefore the number of moles of just hydrogen is going to be this times by 2. You might be wondering, isn't it divided by 2? No, because it's a H2, and because we are going directly, it's from a H, so therefore the H must be that times by 2. So 0.0357 times by 2. 0.0714. Don't know what just happened. So now we can quite easily show that the empirical formula is C3H5O4. So we've got carbon 0.0430. So I'm going to have to do this over here. So carbon to hydrogen to oxygen, we got 0.0430. We got 0.0714, and we got 0.057 divided by the smallest ratio, in this case 0.0430, 0.0430, that's obviously going to be 1. This is 1.6, and this is going to be 1.3. Now we're trying to get C3H5O4, so what we're going to do, all we're going to do is we're just going to times by 3. If we times by 3, we get 3 to 4.8, but since it's pretty close to 5, we'll say 5 to 4. So therefore we get C3H5, the oxygen, O4. And therefore we have shown that the empirical formula of citric acid is C3H5O4. Now 8.2, a 3 gram sample of this is heated to constant mass, and hydrous H3Y that remains has a mass of 2.74 grams. Show using data that these data that the value of x equals 1. So we're going to have to work out the moles of H2O in this case. Yeah, moles of H2O, which we already know, the moles of H2O in this case. So moles H2O equals it's going to be 0. Yeah, because we know a 3-gram sample of this and anhydrous H3Y has a mass of this. So to find out the mass of H2O is just going to be this minus this. So 3 minus 2.74 or 3.00 minus 2.74, which will give you 0.26. So we get 0.26 divided by mR of H2O, 18. Now that will give me the moles as 0.014. And what we're trying to show is that x is equal to 1. So if x is equal to 1, the moles of H3Y XH2O, which is moles of that, is mass 3 over mR to 10. And that is also equal to 0.014. And therefore, since both of them moles are equal to each other, the ratio is 1 to 1, hence x is actually equal to 1 because the ratio is 1 to 1. That's 8.2. And then 8.3, figure 5 shows the structure H3Y. Complete IUPAC name for H3Y. So we've got propane, we've got 1, 2, 3 tricarboxylic acid, but we haven't included this. So what's it going to be? It's on the second carbon. On the second, so it's going to be 2-hydroxy propane 1, 2, 3 tricarboxylic acid, and it says state the number of peaks you would expect in the 13C NMR spectrum for H3Y. So if we look here, we've got 1, 1, 1, 2, 2, got 3 here, and we've also got 4. So therefore it's going to be 4 different. So 4 is the number of peaks you would expect in 13C NMR spectrum for H3Y. 1, 1, so 1, 2, 2, 2, and then you've also got 3 and you've got 4. And that is the end of question 8.